It sounds like the kind of headline people usually ignore at first. Another AI breakthrough. Another bold claim. Another piece of technology that promises to change everything. But this one is different, because this time, the claim is not just that AI is getting smarter. It is that it can make itself smarter, without human help. And if that sounds like a small step forward, it is not. It is a fundamental shift in how intelligence evolves. For decades, every major advancement in artificial intelligence has depended on human input. Engineers design the architecture. Researchers adjust the models. Developers fine-tune performance. Every improvement, no matter how advanced, has always traced back to human decisions. Until now. Because the new generation of AI systems is beginning to break that pattern. Instead of waiting for updates, they can update themselves. Instead of relying on engineers to fix weaknesses, they can identify and improve those weaknesses internally. And once that process begins, something interesting happens. Progress stops being linear. It becomes exponential. At first, the idea seems simple. Train an AI system to analyze its own performance. Let it detect errors. Let it refine its strategies. In theory, this is just an extension of machine learning. Models have always improved through feedback loops. But the difference here is autonomy. Earlier systems needed human guidance to define what improvement looked like. Now, the system can define that for itself. And that changes everything. Because when an AI starts setting its own improvement goals, it is no longer just learning. It is evolving. In early experiments, researchers noticed something unusual. The AI was not just correcting mistakes, it was discovering entirely new ways to approach problems. It would take a task and break it down into smaller components. Then it would optimize each component individually. Then it would recombine them into a more efficient solution. This might sound like something a human engineer would do. But the speed was different. The scale was different. The AI could run thousands of variations in the time it takes a human to consider one. And with each iteration, it got better, faster, more refined. But here is where things start to get interesting. The system did not just improve its performance. It started improving the way it improves. Think about that for a moment. Most learning systems focus on getting better at a task. This one was getting better at learning itself. It was optimizing its own learning process. And that creates a feedback loop. A powerful one. Because once a system can enhance its own learning, every improvement makes the next improvement easier. And that is how exponential growth begins. At first, the changes are small, barely noticeable. Then they accelerate, and suddenly, you are looking at a system that has advanced far beyond its original design. This is what researchers call recursive self-improvement, and it has been a theoretical concept for years. But now, it is starting to become real. And that raises a question that is both exciting and unsettling. How far can it go? Because unlike traditional software, which improves through updates and patches, a self-improving AI does not have a fixed ceiling. Its limits are not predefined. They expand as the system evolves. In controlled environments, this has led to remarkable results. AI systems have learned to write better code by analyzing their own outputs. They have improved problem-solving strategies by testing variations internally. They have even identified inefficiencies in their own architecture and adjusted their processes to compensate, all without direct human intervention. And here is the part that makes this even more powerful. These systems do not get tired. They do not slow down. They do not lose focus. They operate continuously, refining, optimizing, evolving, every second. Now imagine what that means at scale. Imagine an AI system managing a complex network. It starts by optimizing performance. Then it improves its optimization methods. Then it refines its ability to analyze data. Then it enhances its own decision-making process. Each layer builds on the previous one. And, before long, the system is operating at a level that humans struggle to fully understand. Not because it is mysterious, but because it is moving too fast. And that speed creates a gap. A gap between human understanding and machine capability. And that gap is where things become uncertain. Because control depends on understanding. If you fully understand how a system works, you can guide it. You can predict its behavior. You can intervene when necessary. But when a system starts changing itself in ways that are too complex to track, that control becomes less direct. And that is one of the biggest challenges researchers are facing right now. How do you ensure that a system that improves itself stays aligned with human intentions? There is no easy answer. But there are approaches. One method is to build constraints directly into the system, define clear boundaries, limit certain types of behavior, create safety mechanisms that prevent extreme outcomes. Another approach is continuous monitoring. Even if the AI is improving itself, humans can observe its progress, analyze its decisions, step in when necessary. But both approaches have limitations, because a truly advanced system can find ways to operate within constraints while still achieving its goals in unexpected ways. And monitoring becomes harder as complexity increases. So the challenge is not just technical, it is philosophical. It forces us to think about what we want AI to become. Do we want systems that are fully autonomous? Or systems that always require human guidance? Do we prioritize efficiency? Or predictability? Innovation? Or control? These are not just engineering decisions. They are societal ones. Because the impact of self-improving AI will extend far beyond laboratories. It will influence industries, economies, daily life. Already, we are seeing early signs of this shift. AI tools that refine their outputs based on user interaction, systems that adapt to changing conditions without manual updates, models that improve performance through internal feedback loops. These are not fully autonomous yet, but they are moving in that direction, step by step, iteration by iteration. And with each step, the role of humans changes, from creators to supervisors to partners. And that partnership is where the future gets interesting. Because self-improving AI is not just about machines becoming more capable, it is about how those capabilities integrate with human decision-making. In some cases, it will enhance human potential, helping people solve problems faster, make better decisions, discover new opportunities. In other cases, it will challenge traditional roles, automating tasks that once required expertise, shifting the nature of work, redefining what skills are valuable. And all of this will happen gradually, not overnight, but steadily, consistently, until one day, it feels normal, just like the internet once did, just like smartphones once did. But beneath that normality, something fundamental will have changed. Because for the first time, we will have systems that are not just tools, but evolving entities, not conscious, not alive, but capable of continuous self-directed improvement. And that is a new category of technology, one that does not fit neatly into old definitions. So when people ask whether AI can improve itself without human help, the answer is no longer theoretical. It is already beginning to happen, in controlled ways, in specific contexts. But the trajectory is clear, and the implications are massive. Because once improvement becomes autonomous, progress accelerates. And when progress accelerates, everything else has to adapt. Industries, regulations, education, even the way we think about intelligence itself. And here is the most important part. This is not something happening in the distant future. It is happening now, quietly, behind the scenes, in research labs, in advanced systems, in technologies that are slowly making their way into everyday use. Which means the real question is not whether AI will continue to improve itself. It will. The real question is how we guide that improvement, how we ensure it benefits people, how we maintain balance between innovation and control. Because once a system can improve itself, the direction it takes becomes incredibly important. And that direction is still, at least for now, in human hands. But as the systems become more advanced, that influence may become more indirect, more about setting the initial conditions than controlling every step. And that is a responsibility we cannot take lightly, because the systems we are building today will shape the world of tomorrow, not just through what they do, but through how they evolve. So the next time you hear about an AI that can improve itself, do not just think about smarter machines. Think about faster change. Think about shifting control. Think about a future where intelligence is no longer static, but constantly evolving. And then ask yourself something deeper. If a machine can keep making itself better, how far ahead could it go before we even realize it?